Hello everyone and welcome back to another video related to clustering. In this one, we are going to do a next topic which is kernels in support vector machine. So let's get started. Kernels in support vector machine. A kernel is a function used in SVM for helping to solve problems. They provide simplicity to avoid complex calculation. We can go to higher dimension and perform smooth calculation because of it. Now the SVM kernels, there are three types of kernels: the linear kernel, polynomial kernel, and the radial basis function kernel. Types of kernels. Linear kernel are best to apply on linearly separable data. If it's easy to draw a line that separates the two classes, then linear kernel is great for the job. If your number of features is really large compared to the training sample, just use linear kernel. This is an example. Polynomial kernel. A polynomial kernel is a more generalized form of the linear kernel. The polynomial kernel can distinguish curved or nonlinear input space, like this. RBF kernel, also known as radial basis function kernel. The RBF kernel SVM decision region is actually also a linear decision region. What RBF kernel SVM actually does is to create a nonlinear combination of your features to uplift your samples onto a higher dimensional feature space where you can use linear decision boundary to separate your classes, like this. Now the properties. The learning time of linear kernel is worst of all, in between, and RBF kernel is the best. And if you're noticing, polynomial kernel is always in between. The fitting data of linear kernel is worst of all, while RBF best. Overfitting, lowest possibility, RBF, highest possibility. Underfitting, highest possibility of linear kernel and the lowest possibility of RBF kernel. Now the important parameters. C. It stands for regularization. If the data is too noisy, decrease it. It smoothens the curve of a plane. A smaller value of C creates a small margin hyperplane, and a larger value of C creates a larger margin hyperplane. Gamma. A lower value of gamma will loosely fit the training dataset, whereas a higher value of gamma will exactly fit the training dataset, which causes overfitting. This is one example of high regularization and low regularization. High gamma and low gamma. Now we're going to move on to the coding activity, which is going to be in the next video. So I'll see you then.